Welcome back to the shop and to the channel, and we are continuing to work on our power drawbar for the Bridgeport mill. We've gotten quite a bit accomplished here between the base plate and the vertical shafts, the tool shelf, the glide shaft, the pivot shaft, or whatever names I'm giving these parts, but we've got a little bit more to do, and one of those is going to be to actually activate this air tool. We might recall on that last piece we made, I'm calling the handle pivot, it rotates on that longer shaft on the tool shelf. At the top of the handle pivot, we're going to machine this actuator that will mount to it, and it will give us a way of hitting the butterfly valve on this air tool, which will essentially operate the power drawbar. Now I have this piece of steel that I've already machined to the correct overall size. I just need to machine all of the features in it in order to make it into an actuator. Well, in one end of this piece there's going to be two tapped holes, 1/4 tapped holes, that will be for some set screws that I'll use that will actually come in contact with the butterfly valve on that air tool. Well, there's probably a number of better ways to do this, but I figured the easiest way would be to set it up vertically here in the mill vise, sitting on a couple of parallels. And I'll just use this little machinist square to make sure that it's vertical. Well, the first thing I need to do is find the center of this piece. So I've got the edge finder in the drill chuck, and we'll do the normal operation here of finding the front and back and left and right edges and setting up those zeros in the DRO. Well, at the center located, we'll move over about 600 thousandths to drill and tap the first hole. These are going to be extremely close to the edge of this part. And as typical for me, I start with a 120-degree spotting drill. Switch over here to a number 7 drill, which is the tap drill size for a 1/4 tap. And before I run the tap through, we'll put a nice chamfer on here to make it easier for the tap to start. Well, I always like to use anchor lube whenever I'm tapping, and this is a little bit strange here. I never had water come out of my bottle of anchor lube before. It seems to have separated. It's getting a little warm here in Northeast Ohio. Maybe that has something to do with it. I don't know if you ever used anchor lube and seen it do this, but once I shook the bottle up, it seemed to reconstitute. So I put a little bit on the tap and in the hole, and we can get started. Well, I've got it in a tap handle, and it's underneath the Brown and Sharp tap follower. I am going to be bottom tapping this because I want to make sure that there's threads all the way to the bottom of the hole here, so I don't end up losing some adjustment for the button head screws that will be in the back of this thing. I had talked about this tap wrench in a odds and ends video from some time ago, and I'm pretty happy with it. It's fairly well made. It's made by a guy on a manual machine down in Southern California, and it was very reasonably priced. I'll have to see if I can find his email address, and I'll put it in the description. But very happy with it. I've got this one, and I've got a nice small one as well. clean out the hole here with a little bit of compressed air, and then we can move on to the plug tap. I know I don't necessarily have to go to the intermediate plug tap in order to bottom tap a hole. I just like to do it to give the bottom tap the least amount of work. I'm so afraid that I'm going to break a tap after putting a bunch of work into a part that I'm pretty leery about it. I've broken a few, as I'm sure many of you have. Using a tap follower and a good tap wrench certainly minimizes that possibility, but I'm still leery about it, and I try to go slow and careful, and if I feel any resistance, I stop. And it's the same process for the other hole. Well, with these two holes complete, I can loosen the vise. I'm going to take this part and I'm going to turn it 180 degrees because there are two more tapped holes in the opposite end of this piece. And they will be for a handle that will hang off of the front. Well, and just like the other side, we'll first edge find to find the center of the part. We'll go ahead and spot, tap, drill, chamfer, and tap each of the two holes. I won't bore you with the entire process. Well, I'm back over here at the bench. Now that I've got those 4 tapped holes finished, I want to take a look at what I need to do for the other major feature of this part. Near one end of this piece, there needs to be a hole bored at 900 thousandths in diameter. This will fit over top of that handle pivot that we made in the last video. Well, I'm going to set up to machine that bore, and I'm going to put this part on some thin parallels rather than just some standard ones. The bore is going to come close to the edge of the part, not that close that I really need to use the thin parallels, but I'm a little paranoid, and rather than either ruin a boring bar or ruining a parallel, this is easy insurance. Once again, I'll use the edge finder to find the right edge as well as the center of this part. And with my 0 set, I can move in over a little more than 1/2 of an inch, and that'll get me to the location of the center of this 900 thousandths bore. And we'll start the process here by spotting it with the 120 degree spotting drill. Then I'll drill a pilot. Then step up to a larger reduced shank silver and Deming drill so I can have enough room to fit my boring head with a boring bar on it inside this hole. Well, I have a brazed carbide boring bar set up in the boring head on the mill, and we're using the power down feed at about 3 thousandths per revolution, and we'll just keep taking about 20 to 30 thousandths depths of cut. Well, as I get close to the final dimension, I'll use the handle pivot itself just to check to see how close we might be. We're still quite a ways off, so I'll use a snap gauge here to check it with a micrometer just to get a better feel of how much further we have to go. Well, if my camera had an X-ray mode on it, you could see through my hands and see that that handle pivot is just barely wanting to go into this piece, which is probably a little bit wider of a hole than I wanted, but that's okay. That's what Loctite's for. So we can take this out, deburr it, and talk about the next feature that needs to be machined. Well, with the bore complete now, the last features I need to machine are these 5-degree angles on each side to give it kind of a wedge shape. This is more aesthetic and ergonomic than it is functional, obviously. So they don't have to be exactly 5 degrees, but I'm going to try to get close. I'll use some blue marking dye here on the top side in order to give me a nice field where I can mark in the angled lines for the wedges. Well, since I used CAD to lay this out, I know that that 5-degree angle is going to come to about 640 thousandths before the edge of this piece on the side with the bore. So I can go ahead and use my calipers here set to 640 to put a nice easy tick mark on the edges and give me a visual of where this wedge is going to stop. And with the overall width of this part being 1.5 inches, and I want that front wedge to be 1 inch, I know I need to mark 1/4 inch from each of the edges on the opposite end. I just use a straight edge here to connect the lines. And this is one nice thing about CAD is that you can draw this stuff up and let it calculate some of these offsets and dimensions for you. Well, and just as a double check here, I've got this old Starrett protractor that has seen better days. It's got some nasty pit marks on it, but I've got it set for 5 degrees. And if I set it on the edge here, my scribe line is really close to what the protractor is thinking 5 degrees would be. So I think I'm good to go here. Well, to mill this wedge now, I'm just going to clamp it here in the mill vise, and I'll use a parallel on the flat to line up that scribed line with the top of the parallel. So tap this in just by eye, and then once I feel comfortable with it, we'll go ahead and tighten down the mill vise, and we can just run an end mill across this until we touch the line. Well, I have a 5/8 inch end mill and a collet, and I'm just touching off on that corner, and I'm setting the 0 on my knee. And because I laid this out in CAD, I know that I need to raise the knee 249 thousandths, and that should put me right on that line. We'll take this in 100 thousandths passes. Well, that last pass took me right to that line, and it also took me to the line that I scribed on the edge, so I guess the maths don't lie. Well, after deburring the other edge, we've got it flipped over and into the mill vise, and we'll do this again. We'll line it up with the parallel, and then we'll take about 249 thousandths off from that corner. Well, after deburring it a little bit on the Scotch-Brite wheel, I'm ready to go ahead and put these two pieces together. We'll use a little Loctite 638 here, retaining compound on the pivot, and we'll go ahead and put these two together, never to come apart again. Well, with this part complete, I can probably do a little bit of simple assembly here. Well, these holes on the back of this actuator were for some set screws. We'll set those in there. These will actually press on the butterfly valve of the air tool. We'll put a couple in here and see how it lines up. Well, we can pop this air tool here in on the tool shelf, and one thing that has bothered me a little bit is how floppy this thing seems to be. So what I did off camera is I made this little washer with a deep countersink in it. I would have put a deeper countersink in the tool shelf, but I think it would have made these the locations for these two set screws that hold the air tool in place too low. I should have probably started with a thicker piece of stock. And this pivoting piece is held in place with a snap ring. We can go ahead and put that on now. But these set screws here on the back of the pivot, I don't think they're quite long enough. They won't really actuate the butterfly valve. I'm going to take these out and replace them with something that's a little bit longer. Well, I took a couple of socket head cap screws and cut them down because they were too long. I'm probably still going to replace these. I think they're going to be too flat and they're going to cause too much friction on that butterfly. What I think I really want to replace these with is some button cap screws. But I think for now, using these will at least give me the length I need to actuate the butterfly and give this thing a test run. Well, I got a temporary air fitting here and an air hose. We can give this a try on the bench just to see how that actuates, and that might be a little bit on the stiff side. The stiffness is coming from those cap screws. They're just too flat. I don't think they're going to work, but they'll get me by until I get some of those button head cap screws in that will fit. But even so, I don't see any reason why we can't take this over to the Bridgeport and do a little mock-up and see how it does on the machine itself. I have an R8 collet, so let's go ahead and put that up into the spindle nose and we'll give it a try.
Alive! It's alive! It's alive!
And I think as long as I remember which way I need to turn the handle, this will probably work just fine. Well, I'm pretty excited that that's working so far. The test run went extremely well, better than I had anticipated, to be honest. I just need to deal with those set screws on the back of the actuator. Well, we only have the handle and the knob to make yet for the front of the power drawbar. And then I also have this little piece at the top that's a travel stop that will keep the tool shelf from coming up off of the base. Well, I think that's going to be it for the video. If you like the video, hit that thumbs up. Comments are always welcome. I do appreciate it. And if you're not a subscriber, hit that subscribe button so you'll see when the next one of these videos comes out. I appreciate you watching. Thanks again, and we'll see you on the next one.